Solve the following system for all solutions. So we see here that we have a circle and a line. When we have a circle and a line, we're going to want to take the line and substitute it into the circle. So we can either substitute in x or y. Today I feel like substituting in x, so I'm going to solve for x. We can subtract y from both sides, and we're left with x is equal to negative y minus 10. And you'll see here that we have an x value and an x value, so we can just substitute that into the equation. So we could think about it like negative y minus 10 plus 2 squared plus y plus 1 squared is equal to 65. And we could think about this negative y minus 10 plus 2 as negative y minus 8 squared plus y plus 1 squared is equal to 65. And this negative y minus 8, we can think about it as negative y minus 8 times negative y minus 8 plus, and the y plus 1 squared, we can think about it as y plus 1 times y plus 1. Just like 2 squared is 2 times 2, these are the same expression multiplied by itself. And here we can FOIL, or you can use box method. Negative y times negative y is y squared. Negative 8 times negative y is positive 8y. Negative y times negative 8 again is positive 8y. And then negative 8 times negative 8 is 64. And then we can do it with our y values. So y times y is y squared. 1 times y is just y, like 1y. Y times 1 again is just like y. And then 1 times 1 is 1. And then we can combine like terms. So there's a lot of like terms that we can combine here. So let's circle the like terms. So we have a y squared and a y squared. So this is going to give me 2y squared. We have I'm going to try to do it in different colors, an 8y, a positive y, and another positive y. So this is going to leave us with 18 y's. And then we have a 64 and a 1. So this is plus 65. And we'll set this equal to 65. And now this is just going to be a quadratic that we are solving for. So we might have to factor. Let's see what happens. So here we can start by solving. We can see that the 65s will cancel out. So if I subtract 65 from both sides, I'll be left with just 2y squared plus 18y is equal to 0. And then you can see here that I have a greatest common factor of 2y between both of these. So I can factor out a 2y, and I'm left with y plus 9 is equal to 0. And then we know that this expression will be equal to 0 if 2y is equal to 0 and if y plus 9 is equal to 0. So we can say if 2y is equal to 0, if we divide by 2, we'll just see that y is equal to 0. And if y plus 9 is equal to 0, we can subtract 9 from both sides, and we'll get that y is equal to negative 9. So now we have our two y values in this situation, and now we want to find our x values. So to do this, I'm going to scroll down a little bit more. So if y is equal to 0 and y is equal to negative 9, we have to decide which equation we want to use. So I'm going to suggest using this transformed equation that we have up here, because it's already set in the equation x equals. I could have also used this. I could have used this. But it makes the most sense if I'm solving for x to use the equation where we already have it set up as x equals something. So I'm going to set this up as x equals, and x was equal to negative y minus 10. And I'm going to set it up in two places because I'm going to substitute in twice. Here we know that y is equal to 0, which is just 0. So x is equal to negative 10. And here we have negative 9. The negative 9 makes this a positive 9, because the negative times the negative is a positive. And we're left with x is equal to negative 1. So we have our two solutions. We have negative 10 comma 0, and we have negative 1 comma negative 9. All right, and let's see what this looks like on a graph if I wanted to envision it. So we'll see here that we have my circle equation in red and my line in blue, and we'll see that at negative 10, 0, we have our first intersection point here, and at negative 1, negative 9, we have our second intersection point here.